Hello, welcome back. This is the second video in my series on hydrographs. In this video, I'm going to go through step number 1, determining the base flow. I recommend following along in the handout that I provided for you. It's like a supplement on determining base flow. It pulls from a couple different textbooks, including the Gupta text, but it's a good supplement to this video that goes through numbers and an example that will maybe help make it a little more concrete for you. Okay, so what is the base flow? If you remember back to when we first introduced hydrographs, you'll probably remember that there's this rising limb, a peak, you know the time to the peak, and then the receding or recession limb. But there's this section of the hydrograph at the bottom that there's always flow in most rivers, and so there's this base flow. And so we want to make sure that when we're looking at hydrographs that we remove the impact of base flow on the outlet of our watershed. So the base flow is going to represent the interaction between the stream flow, groundwater, and interflow. So there's always kind of groundwater and stream flow and interflow sort of intermixing. There's natural spring spots where you'll see water naturally entering from under the ground into your stream, for example. So that's where we're going to get started with that. So there are a few methods. There are many methods for determining the base flow, and I'm going to present here today 3 different methods and try and represent them on this hydrograph for you. Okay, so method number 1 is the straight line method. Okay, and this method assumes that the base flow is constant, regardless of the flow. So even when a storm passes by, this makes an assumption that no additional groundwater or interflow enters. And the way that this works is that you draw a horizontal line from the beginning of where your direct runoff starts to the intersection with this recession curve. And this recession curve, by the way, pretty much always follows, not always, but can be represented or approximated by an equation that looks like this. So we will come back to that. This QO is the peak flow. Okay, so this straight line method, we just draw a straight line. So for example, from A to B, close enough to a straight line. And then this down here becomes your base flow. And everything up here is our direct runoff that we're going to need for our hydrograph calculation. Okay, so that's the first method. You just assume a straight line, but it assumes that the base flow is constant even if a rainstorm comes in. I'll leave that line on there actually. We'll just have all 3 on there and it'll match more directly what you have in your handout. Okay, method 2. So let me just make a note here that this is A to B on your figure. Okay, method 2 uses a constant slope method for the base flow. this gets a little more complicated. Your first step is to draw a straight vertical line at the peak of the hydrograph. Okay, so I'm going to do that with my orange marker here. Here's my QP. I just remember what QO is, the correct answer for QO. So here's my QP. I'm going to draw a straight vertical line. QO is sort of over here, and that's where the recession curve starts. Okay, anyway. Okay, so we did draw a straight line from at QP all the way down, and then we calculate n equals a to the 0.2 and draw a second vertical line. In this particular case, A is our watershed area. And N is some time after the peak. Okay. Okay, so I'm going to just draw a line here. I'll call this N equals A to the 0.2. Draw my second vertical line. And then step 3 is to draw a line from A, the same A from our first method, to this second line where it intersects the falling hydrograph. Okay, so I'm going to go from A to this point. I did a pretty not perfect job here. So I'm going to go from A to C in this case. And I'm going to draw. Let's not make it dotted. Let's make it straight. A to C. So this one goes from A to C, and it's done mostly in the orange. So you can see here that this has a lot more base flow on the falling limb than the first method. So it does allow some variety in the amount of base flow as your contribution of flow into the watershed from the storm increases. Okay, the last method here that we're going to discuss is the concave method. All right, so step 1, we're going to draw a straight line again vertical at QP. So we have that from the last time. Number 2, we're going to draw a line from A to what I'll call D, from the start of the direct runoff to a point below the hydrograph. And this should have the same slope as whatever's happening before the start of the hydrograph. So let's do that in green. So it's going to follow this same slope. Got it green. Okay. It's going to follow this sort of same slope. Okay. From here to some point D. So this, it would have been the slope of this part of the hydrograph. A little bit hard here to guesstimate what this slope is. It's basically this slope there. But I pulled it up here and it goes to point D. Okay. We're going to do this guy in green. And then we draw a line from D to E. And E is N time periods after the peak. We're going from A to D, and this is the same point as the previous one, so it'll look like this. Okay, so 3 different ways to calculate base flow. Take a look at that handout and go through the example. It also offers an additional method for determining the base flow.